Hello and welcome to the second video in our tutorial series for the COVID-19 simulator. This simulator was developed as part of the EUVABECO project. Today, I'll be guiding you through the various analysis tools available for understanding the simulation results. In section results, subsection plots, there are the trajectories of the epidemiological data and influential variables over time. Observed data is depicted as points, model simulations as lines, and confidence intervals as shared areas. Switch between linear or logarithmic Y-scale by pressing log. Extend a plot by clicking on the forward arrow symbol. Zoom into each plot by dragging the clicked mouse over the respective area. Zoom out by double-clicking in the plot area. Shift X and Y axis by dragging the clicked mouse along the axis. Hover over the plot to see the specific numbers for each respective day. In the subsection metrics, various summary metrics can be found, such as the highest incidence simulated during the simulation period or the total number of new cases. In the subsection overlay, you can compare two metrics on a single timeline to identify correlation and time lags between epidemiological indicators. When comparing daily deaths to incidents, for example, there are shifts in the relationship between both, but when comparing death to hospitalizations, they follow each other more closely. In the trend section, you can see the growth rate to answer the question, how fast cases or deaths are increasing each day, comparing today's total to 7 days ago. Higher values mean faster spread. For cumulative data, growth is always positive. Red sections indicate speeding up. Green phases indicate slowing down. In the lag subsection, you can analyze the time shifts between two metrics. Comparing, for example, daily deaths and incidents, we see that the calculated optimal shift is 10 days, and using the slider, you can see that with a 10-day shift, you optimize the correlation and overlay peak daily deaths and incidents. In the calendar subsection, each row shows daily values as a heat map, while each column represents 1 week of the year. Here you can compare the overall pandemic trajectories in the different metrics. In the subsection peak timing, you see the time delay between peaks and different metrics. These delays reflect the natural progression of disease, increased transmission, which means more cases, which means more hospital transmissions, which means more severe outcomes. However, different disease severity caused by virus variants also play an important role here. In the section Epidemiology, you first have a wave detector, which uses smoothed incidence data to identify distinct epidemic waves. A wave is defined by a peak that rises above 10% of the maximum value with at least 21 days between peaks. In the subsection Outcome Flow, you can see a visualization of the flow of patient through the healthcare system, including the number of all patients and the fraction of patients in each state. In the subsection Ratios, you see the cumulative case fatality rate, which is the number of total cases at a time divided by the number of total fatalities. The ICU hospital ratio is the number of ICU patient divided by the number of total hospital patients. It differs from the proportion of patients who require ICU treatment, as patients admitted to the ICU generally have a longer hospital stay than those only needing general ward care. Finally, you can compare different scenarios, which we will show you in the next tutorials. In the subsection Threshold, you can define different thresholds for each metric and receive an analysis on the number of periods as well as total number of days that the metric is above the defined threshold.